Let's look at a simple vector valued function. This would have maybe been a better first example in the previous segment in terms of ease, but I think I don't have any regrets over showing you that interesting parabola. So if you don't recognize this vector valued function, that's not a surprise because it's simply dressed up in a way that in theory could be new for all of you. Again, I'm using the component form because of the ease of putting it on paper on display for you all. And I know if you surf around through other channels, there's plenty of examples of IJK notation and linear algebra notation. So I'm being a little bit different here. Component form. So we're going to sketch this. We're going to graph, and given that t is greater than or equal to 0, so if we plot points, t is 0, 1, and 2, and 3, and we'll see if we need more points beyond that. If t is 0, the x and y output, now remember, in theory this is a vector, but what we're really interested in are the points the vectors point to. If we start at the origin, when I put it on graph paper, that will be easier to display. So x and y in this case, if t is 0, x is going to be 1 and y is going to be 2. So we're going to treat that as coordinates of a point here. If t is 1, 1 minus 2 is negative 1. 2 plus 3 is 5. If t is 2, 1 minus 4 is negative 3. And 2 plus 6 is 8. And if t is 3, 1 minus 6 is negative 5. And if you can't see it, please note that the x value is decreasing by 2, which is exactly what that says, decreasing at 2 at a time. And the y value begins at 2 and is increasing 3 at a time, so this should be 11 theoretically. Now, let's put some graph paper here for us to use. The point 1, 2 is right here. Negative 1, 5 is right here. Negative 3, 8 is right there. Can you see that these points are linear? They are collinear, we would say in geometry. And negative 5 and 11 would be about here. This line is going in that direction. And in case you missed it in the last segment, you must indicate the direction. Later we'll be more interested in things related to the magnitude. Remember, vectors give us both direction and magnitude. So I never drew the vector 1, 2. What I drew is the point 1, 2. The vector 1, 2 would start at the origin and point to that point. And then negative 1, 5 would point. So this is almost like the graph the vectors point to. It's over there. No, it's over there. No, it's over there. No, it's over there now. And here's where you've seen it before. My students and those who are just visiting, this is parametric form. We very recently looked at parametric equations of lines, but before you get to calculus, you usually study a little bit more about parametric equations. They introduce the parameter t. This is how we will write parametric form. After our first unit, we will pretty much only use the vector function version of that. All right? Next time we'll start sneaking in a little bit of calculus. It'll be fun.